Okay, so 5.1 and actually 5.5, we are talking about areas under a curve, okay? So how we're gonna get an area under a curve, it'd be like this blue part, okay? So if I could just, graph any function, whatever function I wanted, and then I wanna find the area, not just under the curve, but between the curve, which is, some f of x, and the x-axis. So that's what I'm looking for, the area in between. So to get that area, there's a couple ways to do it. We're gonna, in this chapter, learn a very specific way, but there's also approximating areas. So one way that we can approximate is by using Raymann Sums. So Raymann Sums are basically somebody, just kind of realized, well, if you want to find that area, it's pretty close if you can approximate using rectangles or some other figures, okay? We're going to use rectangles and trapezoids, but we're going to start with rectangles. So I basically drew this, and then instead of just shading in the actual area, the exact area, I drew little rectangles inside. And then you can tell if I split this up into 1, 2, 3, 4, 5, 6 rectangles that go all the way up, like my height of the rectangle, right? My base is this little piece. There's, some congruent bases going on. There's 6 congruent bases. And my height of the rectangle just goes to the function itself. If I add up these rectangle areas, I get something pretty close to this. Okay, if I make like 100 rectangles, I get really close to this. If I make an infinite number of rectangles, that's what I'm basically finding for my area. Okay, so we're going to start with, a few less rectangles. We're not going to do 100. We're going to do some. Okay, so that's the basic gist of approximating areas using Riemann Sums. Okay, so there's a couple formulas to remember. One is, of course, well, this is called RAM. This is called a rectangular approximation method. So this part, rectangles, obviously, is rectangular approximation method. So we find it using 2 ways. We either do, well, actually 3 ways. We do LRAM for left-sided rectangles. We do RRAM for right-sided rectangles. And we do MRAM for midpoints. And then I'll show you each one, okay? So here's in general, well, you can kind of see if all the rectangles have the same base, then what we can do is, just like this one, if all the rectangles have the same base, it's just this base, whatever it is, maybe it's like 1 centimeter or whatever, so 1 centimeter times height, and then plus 1 centimeter times height, plus 1 centimeter times height. Well, if you want, you can factor out that base if all the bases are the same. Sometimes they're not, but sometimes they are. So we're going to start with yes, they are. So if they're all the same base, then we can factor out the base, and then we can just add up all the different heights. So, one thing to remember with rectangles is if you have a base, you have one base with one height. One base with one height. One base with one height. But if you count up, how many bases are there? 1, 2, 3, 4, 5, 6. You actually have 6 bases, and then you have 1, 2, 3, 4, 5, 6, 7 heights. So we have to deal with that. We can't have 7 heights. We can only have 6 heights if we have 6 bases. We're going to deal with that a little bit later, okay? Okay, another way that we do it is using trapezoidal approximation method. So we call that TRAM for short. So trapezoidal, basically like Raymann, not rectangular. It's like, it's not rectangular. Okay, so trapezoidal, I think that's the TR, and then approximation method, okay? So TRAM is what we generally call it. And that's our shortened version. Okay, so here's, a normal trapezoid, all right? So I think I drew it for you right here, yeah. So here's like a normal trapezoid, like that. Right? So that's a normal trapezoid that we recognize. We have 2 parallel sides, and then we have a height. Okay, so normally, we actually don't see it like this. Normally, we see it like that. So I'm going to cover these. So normally, here's our base 1 and base 2, and then here's our height. So how do you find the area of a trapezoid? It's 1/2 height times base 1 plus base 2. So right here, I wrote 1/2, here's the height, times base 1 plus base 2. The difference is, for these, that you can see the parallel go up and down. So when we're talking about height for these, it's not going to look the same as this, But it's the same kind of thing. It's just flipped, okay? So what I did is here, this is what we're really talking about. So this is what we mean as a base of our tram, and then each height is different. This is your formula. So you can see where the base over 2 comes from. It's 1/2 of, and then the base is really this part, which is really what used to be the height, right? That used to be the height of a trapezoid. So that's why it's h over 2, which is base over 2. And then you can see, this is kind of weird. I know this is kind of weird, but then we're basically adding up all of our heights, and then we're doing like this one and this one, and then this one and this one, and then more and more. And you can see when I do this one and this one gets doubled. So that's why it's double the ones in the middle, and there's the first one and there's the last one. Okay, so the formula is a little bit weird, but if you did this with each trapezoid, if you did this formula, it would work as well. And we are actually going to do that because sometimes we have to, because sometimes the bases aren't the same. Okay, so we're going to move on to our first example. Okay, so approximate the area under the curve using 4. So that means 4 subintervals, 4 rectangles. That's what they're really saying. Okay, so 4 bases. And you're going to graph each. So for the homework, there's some that you have to graph and some that you don't have to graph. But I want you to start graphing. I want you to see it in your head. I want you to like understand what you're doing. Okay. So the first one I'm going to graph with you. Okay. So we're going to use left endpoints. And then I'm going to go like this, but you can see why this is true. So for left endpoint, sorry. So we're going to use left endpoints, and then we're going to do an XY chart. So starting with -2, ending with 2, we're going to do an XY chart. So you do a little XY chart, and then you have to plug it in. So -2, plug it in. It's going to be 5 minus 4, and then take the square root, and then you plug it in -1. It's going to be 5 minus 1, take the square root. Okay, and then you get these values. Okay, for the base, you can calculate it, or sometimes you can just see it in your graph, right? So you can see there's going to be 1, 2, 3, 4 bases, and we want 4 subintervals. So each one of these differences is going to be our base value for the rectangle. But if you want to calculate it, because it's not always 1, then this is a way that you can calculate it. You just do, this value minus this value. You can do the other way around, but you're going to get a negative. So b minus a divided by n. So that'll always give you the base value if they're all even. Okay, if you're the one doing 4 subintervals. Okay. So here's what I did. I said this is going to be on the very left of our graph. This is going to be on the very right. Okay, I'm going to graph this with you. And then the other ones I'm not going to, but you're going to try. Okay? So we're just going to graph it onto, how do I know that it looks something like this? Well, I can look here. It goes up to 2. It goes up to a little bit over 2. I don't know what that is, but it's a little over 2, right? Because it's a little over root 4. Okay. So -2, comma, 1. And then 1, comma, 2. And then a little bit over 2, and then like this, and like this. That makes sense because it is part of, I'll go like this, part of a square root, but then the inside is squared. Okay, it's a little crooked, but I have something like this. I go all the way down, and I can see my 4 rectangles. Okay, they say left endpoints. I'm going to draw 4 rectangles with left endpoints. This is how I do it. I go to my left endpoint. So this is, so for this rectangle, this is my right endpoint, this is my left endpoint. So my left, I draw to the right. From my left, I draw to the right. From my left, this one's going to be different. I draw to the right, and then I close the empty space. And then this last rectangle, I go from the left, I go to the right, and then I close that empty space. And then I shade in my rectangles very lightly. Do not shade like a crazy person. You're going to shade with a highlighter or with your pencil. You're not using a pen. Okay, so you can see 2 of them are underestimates, right? 2 of the rectangles are underestimates, and then 2 are overestimates. And these are left endpoint Riemann sums. So this is an LRAM. Okay, so do I need this for, I'm going to go like this, so it has the same picture, right? So your picture looks something like that. Do I absolutely need this to find the answer? No, but I want you to draw it. So I'm going to have you graph it in the beginning because I need you to understand how to graph it, and then I'm going to ask for those graphs on the homework as well, okay? So for LRAM, I have my base, which is 1. So each base you can tell is 1 unit, right? There's 4 bases. So there should be 4 heights as well. And for LRAM, it's the left endpoint. So I start here and I use the 1 and the 2 and the root 5 and the 2. I do not use the right one. I only use the left ones. When I'm doing right endpoints, I want you to draw it. The picture is going to look almost the same, but your rectangles are going to look different. You draw it. Or sorry, so final answer, if it's a decimal answer, you put into your calculator, you have a decimal answer, okay? You draw it, and then you check it, and then look at the difference there. So these are our right endpoints. So you can see from the right, I go to the left, from the right, I go to the left, from the right, I go to the left, I'm over, and then from the right, I go to the left, I'm over. Okay, your final answer, you're using your base, and then which ones are our right? It's going to be not the left, so I cover that, and it's going to be the 2, the root 5, the 2, and the 1. So I have 4, because there's 4 rectangles, I have 4 heights, and then that ends up being the same answer. Is it always the same answer? No, but that one is. Okay? All right, I'm going to show you another one. This one, I'm going to say is my favorite because sometimes you have to lie and you have to like things. I'm going to say this is my favorite because this, instead of LRAM and RRAM for left and right, we call this MRAM. And this, so this MRAM, the problem is, this is why I have to lie and say this is my favorite and kind of like love it and cherish it, because these numbers are easy, right? But then when I look at a midpoint, the middle of a rectangle is a decimal. So I need to use like 0.5 and 1.5 and negative 1.5 and negative 0.5. So that's what I did. All right. So I need actually a new XY chart. So these have 4 midpoints, the middle of our rectangles. And you plug this in. And the reason I'm using not decimals is because you should be able to do this without a decimal. And it's easier to do with a fraction. Okay, so I'm going to do 1 with you. Okay, I'm going to do negative 3 over 2. So negative 3 over 2, if you square it, is 9 over 4. And then what is 5 minus 9 over 4? Well, it's 20 minus 9 over 4. So 20 over 4 minus 9 over 4, right? So then you can subtract. So I kind of did it like that. So 20 over 4 minus 9 over 4. So it's going to be root 11 over 2. Okay, so if I take the 4 and then take it out of the radical. And then you do the other ones. You should be able to do it yourself and not copy me. Okay, I want you to draw it and then try to see what the drawing looks like. Use a pencil. And then I'm going to show you mine. Okay, when you draw your graph looks the same, except now you're still going up to where, you're still making the sides. Go ahead and, from your, sorry, I need to re-speak. So you're still drawing the same thing that you drew before, but now you know where the midpoint is. So you're just drawing what you had before, and then from the middle of the rectangle, basically you make it up to go to the middle of the rectangle where that hits the y values. That's going to be the middle of each rectangle. So you can see here, I tried, it's a little hard to be the middle of that rectangle. Here's the middle of the rectangle. So always the midpoint is always going to have a little over and a little under. A little over and a little under. A little under and a little over. A little under, here's the white part, and a little over. So a midpoint is usually very, very accurate. Okay, it's more accurate for sure than an LRAM and an RRAM. Okay, this is why I feel like I need to love MRAMs. Because one, it's trickier, and I have to like give love to trickier things. But also, it's both my name. That's what's Miriam, basically. You know, I mean, I know it's silly, but okay. So then I have my y values. I have my base and all my heights I found from here. And then I add it up. And then if I put it into the calculator, I get that. All right? Okay, so here's the last one. Trapezoids. We're going to do the same thing with trapezoids. So for trapezoids, here's how you draw it. You draw it the same way you did A and B. All right? You draw it the same way. And then all you do is you go ahead and connect the points to each other, because that's how the trapezoid works, right? So you have points on f of x, and then you just connect them. And then you're always going to be a little bit under, or if it's concave up, you're going to be a little bit over. But it's going to be pretty close, all right? It's going to be pretty close. Okay, and then I go ahead and use my formula. What is my formula again? It is base, where was it? Base over 2. What was my base? My base was 1, so 1 over 2. And then you take the left, right here, the left and the right height. So here's the left and the right, and the middle ones you multiply by 2. Because really what you're doing a shortcut of is you're doing half of this plus this, and then half of this plus this. So all the middle ones, they get doubled, okay? So we're going to try to remember that formula, but that's why it's true. And then you calculate it, and then you get that answer. And then I'm going to ask you, what is the actual answer? How do you get an actual answer? I'm going to show you. You have to use a graphing calculator. So in my graphing calculator, we're going to do an actual answer. So you're going to press math right here, math. And then what you want to find is, you're going to scroll down just so you can see it. You want to find this. It's always going to be number 9, I think, on your calculator, but you want to find an integral. So that's what we're actually finding. The actual area is called an integral. And then we'll look, ooh, it got super dark. Let me turn on the light. Okay, so it's actually an integral. So we're not finding the derivative, we're finding an integral. Okay, I'm going to press enter. And then basically I am going from, what were those x values? I'm going from -2. Make sure that's a negative and not a minus. All the way to 2. And then I put in my function here. So my function was the square root of 5 minus x squared. And then I'm in terms of x. So I put an x there, okay? So these are my x values. This is my function. And then I'm telling it, just like when you find a derivative, you have to say this is in terms of x. So then I press enter, and then that's my actual, what happened? Oh no, did I do something wrong? Oh my gosh. I think I plugged it in wrong the first time. I think this is right? I don't think I plugged it in wrong. Okay, so let's fix that. I think it should be that. All right, 7.54. Okay. And then can you, for number 2, plug it into your calculator. Plug it into your calculator. Approximate. It says approximate using R and tram. Just kidding. Okay, you do it. You do it. So you have to do this on your paper. Sorry, I'm not going to show you the answers. So you do it on your paper, and then you hopefully, 4 subintervals, and you hopefully get these 2 answers. So I want to see, you don't have to draw the pictures, but you're doing the XY chart, okay? And you only do one XY chart, actually. You just do one of them, and then it gives you answers for both. So go ahead and do that. I'll ask you for that probably on the homework help line. I'm going to put this question up. So for A and B. So you'll just show your work for A and B. And then find the actual value. And I guess I should check this one on the calculator. So if I'm right, then okay, that's cool. Math, 9, let's try again. 1 to 5, 4x squared in terms of x. 165.3, yeah, okay, so I don't know. I don't know why I wrote the other number. This was right. It looks right. Okay, all right, on the back. Last two. These are actual problems, okay? So these came from the AP test, I know. Here is something that they like to ask a lot. So let's say they give you a function, and then they say it's continuous, and then it's 0 to 6, and then it has those values. And then it's saying, okay, the trapezoidal approximation with 3 subintervals is 52. So they want 3 subintervals. That's really nice because I can see 1, 2, 3 bases. So that's perfect. I don't technically need to, do my formula because I can see what each base is. It's from 0 to 2, 2 to 4, 4 to 6. Each base is 2. But when I do my formula, I also see 2. Okay, so it's going to be 6 minus 0 divided by 3, which is 2. Okay, so then go ahead and do your work for trapezoidal, and you're solving for k. So don't copy me, but you're doing your work, you're solving for k, and then you get 10. Maybe I'll ask for your work on the homework helpline as well, okay? Did I do my, oh, just kidding, I'm not going to ask for your work. I'm going to show you now. There you go. So you write it in. So this was the work for it. And then you add and subtract and multiply and do all that stuff. Okay? Okay, here's the last one. This is pretty important. So this is like a question that might get asked, but it's pretty straightforward. This one, this one, I'm going to go like this. You are doing on your own, okay? So this one, you're writing it by yourself. So this says, okay, what about if you were to, oh, what happened? Oh no. Where do these numbers come from? Am I crazy? Example 4. Oh no, where did it come from? Oh, it came from the picture. Duh, yours looks different. I want you to find RAM on here. I don't have it on my paper. So do 1 through 9, and those are the values, okay? So 4 subintervals, 1, 2, 3, 4. Sorry, I slept way too many hours last night. So 4 subintervals, which is pretty easy. But here's the issue. Do you see how this base is 2, and this base is 3? And this base is 3, and this base is 2. The bases are not the same. If the bases are not the same, when you do your RAM and when you do your tram, you literally need to find 4 rectangles. So you have 4 different bases and heights. You have 4 different, 4 different rectangles. So what is the first base? The first base is 2. What is the first height? Is it -3? Or is it 1? Well, you're looking for RAM. For RAM, you have to use the 7, which means you also have to use these numbers, which means you are not using the -3. So when we look at our numbers, we have a 2 as a base and then a 1 as a height. We have a 3 between the 2 and the 5, and then we have a 3 as the height. We have a 3 between the 5 and the 8, and we have a 6 as the height. We have the 2 between the 8 and the 10, and we have a 7 as the height. And then we just multiply and we add. Okay? So that is 4 separate rectangles. Okay. For tram, you need literally 4 separate trapezoids. So you have 4 trapezoids where the base is 2 and 3 and 3 and 2. All right, let's see how this works. So there's going to be 4 trapezoids. I decided to write it out for you. So I was like, okay, the first one is going to be this little base. And then instead of writing it the other way, I like to think of it this way, right? So 1/2 base 1 of height 1 plus height 2. 1/2 base 2 of height 1 plus height 3. So I like to write it this way just so I think of it, like flipped. Because usually the base and the heights we see like this, but now the base and the heights are like that, right? So I just like to write it this way. Okay, so 1/2, and then what is our first height? And then our second height. Well, our first height was the -3 and the 1. So I see the -3 and the 1. This is my first base. This is my second base, and then 1 and 3. This is my third base, 3 and 6. This is my fourth base, and then here is my 6 and 7, which are the last 2 heights here. And then you're doing it by hand, because technically you're not supposed to be using a calculator for these. I don't know if the AP test is going to be watching you or letting you use your calculator, but technically you wouldn't have a calculator on a regular year for this, okay? So you have to figure it out by hand, and then you have that final answer. Technically though, if you didn't have a calculator for this and it was a free response, you could box this. Once it has all the numbers in it, you can box it as your final answer and be like, I'm done. If it was free response. If it's not free response and it's multiple choice, you're gonna have to find that answer. Okay, so there you go. Good luck. Your homework is actually gonna be worksheet number 40, which I went and put on here. Okay, so you can see, I want you to do 3 graphs for number 1 and the answers. And then for trapezoidal, no graph, but I want the answer. For E, I want you to find the exact area on a graphing calculator. So you're still doing A, B, C, D, E. So you're doing 3 graphs, and then you're doing 5 answers. For this, you're doing no graphs, and then you're going to do 3 answers for each. But for this, you're doing 1 graph. For this, you're doing 1 graph. But 3 answers for each still. And then here are all the answers. And then we'll go over all the answers. Oh, this is actually Monday. So your homework for this weekend is just to copy the notes. But your next homework for this section is going to be right here. So you can get started on it early if you want. All right? All right. The end. See you soon.